So your math teacher told you about this dot product between vectors, with two formulas coming out of nowhere and magically giving the same result. You can actually prove this by using the law of cosines and sacrificing a black goat. But there's a very simple intuition behind the dot product that explains both formulas. Imagine a metal plate heated to different temperatures at different places. The lower left corner is cold and the upper right corner is hot. One way of describing this is to state the rate of change of temperature in both x and y directions. Both rates, written as a vector, are called a gradient. Just don't think of it as a translation vector since its components are not lengths. It allows us to find the increase in temperature along any vector by multiplying each of its components with the corresponding rate of change and then adding. Recognize something? What about this vector? It goes down just the right amount to counteract the increase in temperature along x. So along all these parallel lines, the temperature stays the same. These are called isotherms. But this means that at 90 degrees from that, the temperature increases most. How fast, you ask? Simply divide the change in temperature by the length of the vector. This turns out to be nothing else than the magnitude of the gradient, found with Pythagoras' theorem, except that these are not geometric lengths, but rates of change. We can therefore draw arrows along that direction and have them represent the temperature gradient. The length represents the rate of change along it after setting a scale. So you can calculate the temperature increase along any vector either as before, using the component formula, or you can split the vector into its components along the gradient and at right angles to it. Only the first actually makes a contribution. We find it by multiplying the vector's length with the cosine of the angle between, multiply again with the magnitude of the gradient, and you know by how much the temperature has increased. Unless, of course, you already knew that from the component formula.